Welcome. Today we're going to talk about weight initialization in neural networks. We'll explore what weight initialization is and why it matters so much for training effective neural networks. Let's start by reviewing the basic structure of a neural network. A neural network consists of layers of neurons. These neurons are connected by weights, which determine how information flows from one layer to the next. The weights are the parameters that the network adjusts during training. These weights represent the strength of connections between neurons. So what exactly is weight initialization? Weight initialization refers to the strategy used to set the initial values of these weights before training begins. Before any training occurs, we need to give these weights some starting values. But we can't just use any random values. The choice of initial values can significantly impact how well and how quickly the network learns. Let's explore what can go wrong with poor weight initialization. There are two major problems that can occur: vanishing gradients and exploding gradients. First, vanishing gradients occur when gradients become extremely small as they propagate backwards through the network. This causes neurons in earlier layers to learn very slowly or not at all, effectively dying during training. On the other hand, exploding gradients occur when the gradients become extremely large, causing weight updates to be too large. This can lead to unstable training or cause the network to diverge completely, making learning impossible. Now, let's look at some common weight initialization methods that help address these problems. First, let's consider zero initialization. This means setting all weights to zero. But this is generally a bad idea. If all weights are the same, all neurons in a layer will learn the same features and update in the same way, making the network useless. A better approach is random initialization. Here we sample weights from a uniform or normal distribution, but naive random initialization still doesn't solve the vanishing/exploding gradient problem. Fortunately, there are better initialization methods designed to address these issues. Xavier or Glorot. Initialization is designed for networks with tan or sigmoid activation functions. It draws weights from a distribution with variance based on the number of input and output connections. The key insight is scaling the weights to maintain similar variance of activations and gradients across layers. He initialization is a modification of Xavier designed specifically for ReLU activations. It's similar to Xavier, but uses a different scaling factor to account for the properties of ReLU activation. Other modern approaches include orthogonal initialization and layer-wise adaptive initialization methods. Let's see the practical impact of different weight initialization methods. Here's a comparison of training curves for a deep neural network using different initialization methods. With poor initialization, the network struggles to learn, with slow convergence or getting stuck. With proper initialization like Xavier or He, training progresses much more smoothly and converges faster. Here are some practical tips. For networks with tan or sigmoid activations, use Xavier initialization. For networks with ReLU activations, use He initialization. When in doubt, use batch normalization in addition to proper initialization. For very deep networks, consider residual connections, ResNet, to help with gradient flow. To summarize, proper weight initialization is critical for effective neural network training. Weight initialization affects how quickly your network learns and whether it converges to a good solution. Poor initialization can lead to vanishing or exploding gradients, making training difficult or impossible. Modern methods like Xavier and He initialization are designed to maintain appropriate signal flow through deep networks. Remember, even with good initialization, other techniques like batch normalization, careful learning, rate scheduling, and architectural choices are still important for optimal neural network training. Thanks for watching.